Today, we're heading to one of Australia's most breathtaking natural landmarks, the 12 Apostles, along the iconic Great Ocean Road. But we're seeing it through a very different lens. Our guest today is Associate Professor Stephen Gallagher from the University of Melbourne, a leading micropaleontologist whose work dives into the microscopic fossils hidden within ancient rock layers. With research spanning from Antarctica to the Atlantic and over 120 published works, Stephen has spent decades uncovering Earth's climate history, one microfossil at a time. Today he joins us to reveal what these tiny fossils can tell us about the dramatic past of the 12 Apostles and how this world-famous coastline was shaped over millions of years. I'm Ian Bunston. Welcome to Monday Matters. Welcome, Steve. Great to have a chat with you this morning.
Great, yeah, great to be here. Nice weather for depending on where you are.
Certainly is, and we're looking forward to this discussion with you. Stephen, for those of us who admire the 12 Apostles from the surface, and I'm one of them, I've seen them about 3 times in the last 12 months, what exactly are microfossils and how do they help you uncover the history hidden within these coastal rock formations?
Well, if you look at the sea stacks, most people, and actually if you visit the sea stacks and then get onto the steps, you look at the rock and you see essentially nothing, just grains, like small grains. And most people dismiss it as sand, pieces of sand. But actually, we have been able to, if you break them up chemically and use sieving and water sieving, you can actually reveal that these rocks are actually essentially all fossils, microscopic fossils. Now, they're not just all one thing. There's loads of species in each little sample. So say take the yellow layers, those yellow layers that everybody loves in the scene. Every scene has those beautiful yellow layers and the gray layers and so on. And the yellow layers, if you look at them really closely, they're full of tiny smashed up shells, clams, bits of a thing called a bryozoan, which is a colonial animal, a microscopic animal. And then there's these fantastic little things that look like popcorn. If you ever see a picture of them on the internet, and these are called foraminifera, and they're one-celled animals, like an amoeba with a shell. And one of the fantastic things is there's so many of them. And if you look at any apostle, and I've done the sums because I've looked at each sample, to say I know every single fossil in the apostles is hopefully not an exaggeration, because there's hundreds of species of these things in each gram. And if you look at each gram, you get about 20,000 of them. And then you scale that up to one of the apostles, like the biggest one you look at, you end up with 76 trillion microscopic fossils in one of those sea stacks. And so when everybody goes there and sees lumps of rock, I just see piles of fossils, just an infinite amount of fossils. So the opportunities for further work and understanding of these apostles is just waiting to be investigated.
So, Stephen, how do these microfossils then uncover the history of the past? What do you see in them? What do you find in them?
Well, just let me have a slight aside. So say everybody, if you've been to see the pyramids, right? Everybody goes, ooh, fantastic pyramids. It's a good analogy actually in this situation. So when people see pyramids in Egypt, right, I see piles of fossils, because each of those pieces of limestone is made of some of these microscopic things. And so there's an endless amount of fossils in a pyramid. And so while I'm not an archaeologist, but I just go, oh, wouldn't it be great to take a sample and look at these things? So basically, these microscopic fossils, there's 2 different types, the ones that float in the ocean and ones that live on the seabed. And the ones that float in the ocean are really actually beautiful. They have these sphere shapes. Some of them are perfect spheres. Some of them look like actually almost flowers. Well, actually, there's one that looks like that. Anyway, those things are extraordinarily good to get ages of layers. And so they evolved really quickly and then they became extinct quite distinct times. So when we have evolution and extinction and they come together at very short periods of time, and when I'm talking about short periods of time, I'm talking about a million or two years old, and we can get very, very precise ages for some of those layers. So one of the layers in the middle, on the iconic photos, you see there's a gray layer in the middle. That's 11.6 million. And was it October the 4th? Perhaps. Oh, no, no, that's an exaggeration. We can't get ages as close as October the 4th. Probably the same week, I would guess, back millions of years. And then the little critters that live on the seabed, we can actually get, they are very, very kind of sensitive to environment and climate. And so the changes of assemblage, as we call it, all the critters on the seabed, is related to sea level change and climate change. So we can actually use these things to actually get the environment, the climate, and the exact age of the layers.
Quite remarkable. Now,
Mm.
Stephen, your research spans environments from the Antarctica to tropical regions. What makes the Great Ocean Road and the 12 Apostles such a significant site for understanding Earth's past climate?
Um, Certainly, as you said, I have traversed the world from Antarctica to the Sea of Japan. I've in the Sea of Japan. Actually, I was on two main seagoing expeditions, drilling the seabed for 2 months, stuck on a boat, drilling the seabed. And while that was fantastic, that was amazing actually, the to be on such an expedition with with 30 other scientists and a crew of another 60 just working to drill stuff on the seabed. Um, it's just the sea, and you're looking at the sea as far as you can see basically. And so, what makes the 12 Apostles unique in insofar as that appearance, and in fact, I've also worked on the North Atlantic, I've had a PhD student do work on the North Atlantic. And once again, it's the stuff underneath the sea that we get. We get these little cylinders of core beneath the seabed to get climate stories. But once again, it's the sea. And so when you go to the 12 Apostles, not only can you see those layers, which is what I've always been looking at, layers, but you can see them for tens of kilometers. And so you can see if there's anything change on the layers that go for tens of kilometers. And it's an extraordinarily kind of emotional thing to see layers go on for almost ever. And the 12 apostles are unique for the age of the layers that we have, I think, in the world. I think the nearest layers that could be like that are in Iraq or Iran. And field trips to Iran and Iraq, I think they're pretty limited for us folk. You know what I mean? And so there's really no place that it's easily accessible to see these layers that go on forever and ever, like just an extraordinary record of layers and climate and various ages.
Stephen, when you examine these sediment layers then that you're talking about, the dating back millions of years, what have you discovered about how this coastline has changed over time?
It depends on what time scale you're looking at. And so there's different levels of time scale here. There's millions of years and there's thousands of years. And
Let's take thousands of years.
okay,
Bring us close to us.
okay. We can go from what I would call the end of the story to the beginning. And the end of the story is what everybody sees are the sea stacks. Everybody goes there, takes photos, looks around, and sees these amazing sea stacks. And if when you're thinking about millions of years, and as I am always thinking of millions of years and actually thousands of years, um, those millions of years of layers everybody are looking at, right, is like a 24-hour clock. So let's say if it's 24-hour clock, those millions of years represent almost all that time. And those sea stacks formed in the last minute of that 24-hour clock. And so to me, everybody just goes, yeah, but that's a minute of geological time. But nevertheless, those sea stacks are young. And as far as we can see, they're only a few thousand years old, not millions.
Okay. Now, also, I have to ask you that I believe the layers aren't totally horizontal, they're slightly on an angle. What's the
Yeah.
story behind that?
Well, the exciting thing in my opinion, that if you look at those things, everybody goes, ah, they're like layers in a cake. They're like flat layers, and then they walk away. But if everybody looks at those sea stacks and then look at from landward to seaward, they're slightly tilted, as you say. They're only a few degree tilted. And I would recommend you have a look at the conversation piece that I've written, and you can pull out the paper that we've done, which has lots of pictures, by the way. So it's like a magazine. So if the technicality is it's pitched for scientists, the evidence is there that all the layers are tilted, of course, and the layers are buckled. And when you go to the seas, the lookout, and you look landward away from the sea stacks, there's these tiny little faults where the layers are broken. And those that is what we have worked out is that by dating the last layer, the final layer in those yellow layers, which is at Lockhart Gorge, which is about 5 kilometers due west of the main 12 apostles, that was 8.6 million, that last layer. And so what it means is that the layers went from being underneath the sea to above the sea. They got popped out of the sea after 8.6 million. And so they went from sea to land, and that whole landscape has been, that whole area from 8.6 million to present, well, until a few thousand years ago, was just simply land, rolling hills. And the reason why that is that the Australian plate, we're all aware of plate tectonics, I hope, and earthquakes and things. We're in the middle of of a plate, and Australia is moving north at a blistering 9 centimeters a year. So hold on to your seats, everybody. It's hitting Papua New Guinea, and Papua New Guinea's popping up. But it turned out that the the Pacific plate started to buckle up against the Australian plate, and the Australian plate kind of tilted and folded and so on and so forth. From actually about 12 million, but it reached the 12 Apostles area about 8.6. And the good old Otway Ranges popped out of the ocean at about 8.6. So they were underneath the sea. If you know the Otway Ranges, they're pretty high.
Hmm.
They were underneath the sea and then they popped out. And so, yes, that's why all the layers are tilted.
So it's the movement of those tectonic plates. It's actually tilted it to one side. Is that what you're saying?
Well, yeah, well, it's actually the movement of the whole of the Australian plate. In other words, the Australian plate kind of got kind of squashed and just kind of just very, very slightly wobbled like this and produced earthquakes.
Hmm.
Um, so it was pretty amazing
Hmm.
to get that information.
Stephen, on my previous visits, which has just been recent to see the 12 Apostles, I was trying to count them from the viewing platform and I made a mistake. I thought there were just, I could see five one way and two the other, but I believe that currently there are eight. Is that correct?
The numbers, if you once again, I recommend you have a look at my pitch and my paper, because I'm fairly dispassionate about the numbers in my paper, and I'm not saying dismissive of the last time, but I've basically my quote is, these are ephemeral features in a million year history. So they're a temporary thing so the numbers don't concern me that much, but I did dig into the origin of the name. And if you look in that paper, I found the first mention of the name 12 Apostles in the literature. It's out there. It's 1897, Christmas Day in the Age. The sound piglets, which is what they were called on the Admiralty charts, that's what those features were called. And in fact, the sound piglets includes even Lockhart Gorge, which look like a pig, like a sow, and all the little sea stacks are the piglets. Anyway, the first time it was mentioned was in that age newspaper as the 12 Apostles. And the person didn't even mention the number. But there were two that disappeared in the last while. And there's a couple of, I know what sea stack you're talking about. If you look to the east of the viewing platform, there's two random sea stacks
Hmm.
towards Gibson Steps.
Yeah.
They're called Gog and Agog. They're not one of the 12 apostles. I was shocked actually myself a few years ago when I talked to the locals and they go, they're not part of the apostles. And so if you take those two away, there are seven remaining. So the six main sea stacks and one quite small one, which I didn't count in my paper section, my paper. So there could have been up to nine sea stacks, never 12.
So do you think then the signage down there at the center and the viewing area should be updated a little bit to be give us more clarity?
Um, that's contentious. I think they should be called the sound piglets. See, just rebadge the whole thing sound piglets. There is actually a shop or a dairy thing called the Sound Piglets down there. I think we're too long on the art marketing realm to pull it back to the original. The numbers, I think the signage, if you're looking at the signage at the lookout, it would be fantastic to change that signage because if you go there, there's a picture of a fairy penguin. I think there's even a picture of an octopus. And when you're looking from 40 meters up at these massive sea stacks, what you're thinking about is, my goodness, octopus. I know. I can see the octopus. And they don't tell us about the sea stacks. There's absolutely no information. There's a bit about cracks and things. So it'd be better to focus on, I hope, the signage of what they're actually seeing. And yes, how many of them are there? You can have a kind of a quiz type thing on the information thing. There is a visitor center that's going to be built, or it's nearly finished, and they have plinths. They call them plinths. They're like table things, and there's 12 of them in the visitor center. I wonder why.
Well, Stephen, I'm interested too I mean, you've done some dramatic research. So from your findings from the 12 apostles, um, how do they help us better understand climate, or the current climate patterns? And what maybe the future holds for the coastal environments like this one in relation to sea levels and ocean conditions?
Um, well, if you look at the layers as like tree rings or layers in a cake. Tree rings is a better analogy in terms of what the layers are holding, the information. Just like tree rings, they are annular or they're every year climate change records. The layers themselves are reflect the climate. So, for example, if you look at the layers and you see a gray layer, that's our evidence would suggest that's a higher sea level. And if it's a yellow layer and they alternate, that's sea level changing. And that's warm climate, cold climate, warm climate, cold climate. But it's actually warm climate, cold climate in a time when climate was warmer than today. And so if you go back to 14 million or so, or beyond 14 million, the layers in the limestone that forms the sea stacks record a time when temperatures were 4 degrees more than today. Sea levels were higher. Um, and actually, we even had some of these little tropical things pop in to visit us. And those tropical things, these tropical microscopic fossils, that's the last time they leave this whole margin. So basically, we can go into the past and look at times when conditions, as anticipated or predicted for the future, the next 100 years or beyond, um, when uh, actually carbon dioxide levels were higher. And in fact, there's estimates of carbon dioxide levels back at 14 million, which are 480 parts per million. And 480 parts per million doesn't seem like much, but the background state since that time has been 170 to 250 parts per million, which doesn't seem much, but that's the ice age background, 170. And today, thanks to our good work, it's 430 parts per million. I mean that in a ironic way. We haven't done good work, and we're back to 430 parts per million. So that's quite bad in terms of carbon dioxide levels and greenhouse gases. And it's predicted that carbon dioxide levels could get up to 480 parts per million in 100 years or more. And so we can go back in time to see what happens to plants and animals during this time period and see how big the sea level was and the changes so that we can then just like understand potential consequences in the future in 480 parts per million greenhouse world. But the caveat with this story is that the change in climate 14 million years ago happened over thousands, tens of thousands of years. In the future, there's an anticipation it could happen in 100 years. So it's kind of what we call an analog, but it's not really because it's much slower. So anyway, but at least it gives us a kind of a background state of the world during that time, during a greenhouse time. So it's very, very nice. It's the standard. It's not the standard. It's the way we always approach climate records.
So, Stephen, just for clarity, trying to put it into simple terms, and for someone like myself who's
Yeah.
a novice in this area, in terms of, say, from your research for predicting for the next 100 years, from your research, do you think is perhaps predicted in terms of global temperatures and also the levels of the ocean?
Well, the one thing that we do have a better control on in the past is sea level change. We have a good idea of sea level. And just to give you an idea, the yellow layers and the gray layers, the sea what was it, about 50 meters. They were deposited in sea that was about 50 meters. And when you go back in time to even 15 million, it was about 30, 40 meters higher. Um, the problem also with that comparison, of course, is Antarctica. Well, Antarctica is not a problem. It's fantastic. Antarctica has different ice sheets. So it's got an ice sheet on the east side and the west side, and it's quite big. And about 14 million, 15 million Antarctica, there was only one ice sheet, the East Antarctic ice sheet. And there wasn't even small glaciers in the Northern Hemisphere. There weren't even Greenland ice sheets. So that's worrying, kind of, because there's only one ice sheet back in time. But fortunately for us in the present environment, the Southern Ocean is quite a fantastic insulator of the ice down in Antarctica. So basically, I think the Southern Ocean is more vigorous than it was during that time, and it's actually frozen more ice. So we have a bigger ice sheet today. However, if you melt a big chunk of that ice, the West Antarctic ice sheet, and scientists are worried about that, um, yeah, you're going to get 6 meters of sea level change, and better not be living in Holland and Vanuatu or whatever during that time.
Hmm.
So it's not, once again, it's not quite an exact mirror of the future, the past, but at least it gets us thinking about all the controls on the climate and the sea level.
Hmm. Well, Stephen Gallagher, Associate Professor here at Melbourne University, thank you very, very much for your time today and sharing your research and what's been going on. It's certainly a fascinating area, and you've certainly created curiosity and you've created interest for us to pursue understanding this whole area and what's going on more. So thank you very much for your time and being a
Thank
guest here
you.
at Monday Matters.
Thank you.